How does differentiation connect displacement, velocity, and acceleration? Let's start with the displacement time graph, where displacement is represented by the letter x, and time is represented by the letter t. If you want to find the velocity on a displacement time graph, what you are really doing is finding the gradient of the graph. For example, let's look between t equals 2 seconds and t equals 6 seconds. Suppose the displacement changes from 12 meters to 24 meters. That means we travel 12 meters in 4 seconds. To find the velocity from this, we do 12 divided by 4, which equals 3. But the important point here is not the specific number. In general, what we've calculated is the change in displacement divided by the change in time. Mathematically, this can be written as delta x over delta t. And yes, this is literally the gradient of the line. In our current example, the gradient never changes, so the velocity stays constant. But what if we want to find the velocity at a specific point along a curve? Let's say we want the velocity at t equals 0.4 seconds. If we use the same method, displacement change over time change, we will only ever get an estimate because we are using two separate points. However, just like in differentiation, if we make the time interval smaller and smaller, we get closer to the true gradient at that exact point. If we make the interval infinitesimally small, we get the derivative of displacement with respect to time. This gives the exact gradient at that point. This is why the derivative of the displacement function is the velocity function. So, if you are ever asked to find a velocity function, simply differentiate the displacement function. Returning to our example, if we want the velocity at t equals 0.4 seconds, we just substitute 0.4 into the velocity formula. This gives the velocity at that exact moment, which will match the gradient of the displacement time graph at that point. So hopefully it's now clear why the derivative of displacement equals velocity. But what happens if we differentiate again? What is the derivative of the velocity function with respect to time? In plain English, that's the change in velocity over the change in time. And the rate of change of velocity is simply acceleration. So, differentiating the velocity function gives the acceleration function. And that's how differentiation links all three: displacement, velocity, and acceleration.